Okay, hi. So I'm going to go over chapters 3 and 4 in biochemistry. So 3.1 is thermodynamics. So basically, life is made up of chemical processes, and then they all have to do with the storage and the use of energy. And so this is like ATP, right? And then we use that energy to like build structures and stuff, and that's like, the biological macromolecules, proteins, carbohydrates, lipids, etc. And so basically, if life is made up of these chemical processes, how are those being regulated, and how do they go, right? Because there's this big activation energy, and this is like the bottleneck. This is why all the processes don't go all the time, because there's this big hump that they have to get over. And so then basically all these chemical processes are run by enzymes, right? And what the enzymes do is, transition states in that you're learning about in OChem. What they do is they stabilize that transition state, because this is the transition state here, right? That's the thing of the highest energy. So the enzyme, the protein, like at the active site, there's all those amino acids that have certain properties, like different charges, different like pH, different intermolecular forces, and then that is going to stabilize like the transition state, basically. So maybe if the transition state is a negative charge, maybe there's a positive charge at that active site, so basically that's what the enzyme does, and so it makes it way easier for these biological processes to go. So thermodynamics is the study of energetics of chemical reactions. So thermodynamics is the part with it's the one where you learn about the Gibbs free energy. Thermodynamics includes, I think, enthalpy. That's where the thermo comes from, like the exothermic, endothermic, that kind of thing. Kinetics is something different. We'll get there. Thermodynamics has nothing to do with how fast the reaction goes. That's kinetics. Thermodynamics has to go with whether it's spontaneous, whether like the products are at a lower free energy than the reactants. So there's kinetic energy, potential energy. So the first law of thermodynamics is that the energy of a system is constant. So if your system is losing energy, it's not disappearing, it's going into the universe, right? The energy of the universe would go up. That's the first law. The first law of thermodynamics is the energy of a system is constant. So that one's easy to remember. And then the second law is that entropy increases. And so entropy is just disorder. And then there's no third law. That's nice. Or maybe there is, but we don't care about it. Okay. So you probably remember this one. It's delta G, the change in free energy, change in Gibbs free energy, equals delta H, the change in enthalpy, minus the temperature times the change in entropy. And so the more negative your delta G is, the more spontaneous your reaction is, right? That's the difference between the energy of the products and the difference between the energy of the reactants. And so if you have a really negative enthalpy, if it's very exothermic, that's really good for spontaneity. And then also if you have a really positive entropy value, which is like disorder, right? Like if one molecule becomes two molecules, two smaller molecules, that increases the disorder, right? That increases entropy, and that's what the universe naturally wants to go to. And so if you have a really high positive value there, then it's going to be negative, and so that's going to overall make it more spontaneous in the delta G. Let's see. Okay, it says the delta H, which is the enthalpy. Remember, this is like exothermic, endothermic. It equals the change in the change in the bond energies plus pressure times change in volume. So what this means is if the change in your bond energies is negative, then that means that your final bond minus your initial bond is negative. So the energy in the final bonds is lower. So that means it got more stable. So therefore it's exothermic. So in a cell, most of the reactions are going to be in liquids, in like your blood, or like in the inside of your cell. So there's not going to be any change in volume. that's going to be 0. And so basically, delta H, your change in enthalpy is basically your change in bond energy, and that's it, which is nice. Okay, delta G negative, spontaneous, yeah. That if your delta G is negative, then that means that it's the equilibrium is going to be on this side, like the products are lower energy.